All right, let's look at the mean value theorem. The mean value theorem is basically Rolle's theorem, but slanted. In other words, instead of having to have 2 points that are at the same y, that have the same y value, you can take one of these points and move it so that you have 2 points with different y values. What this says is, well, let's say we've got a function that's continuous and differentiable. It says if you pick any 2 points on that, I'm going to pick that one and this one. But pick any 2. If you draw a dotted line between them, then somewhere in between those 2 points, you can find somewhere where the tangent is parallel. And I'm just kind of eyeballing that there, but that's what the mean value theorem says. Somewhere in between, you can find a tangent that's parallel. Now, it does require that the function is continuous and differentiable between those 2 points. So let's look at the formal statement of this. Let f be a function that is continuous on AB and differentiable on AB. Then there's at least one number c in the interval from a to b that satisfies this. Now, what this is, this side over here, that's the slope of this dotted secant line, because this is the point b f of b. This up here is the point a f of a. And so if you work out its slope is going to be f of b minus f of a over b minus a. And of course, f prime of c, that's just the slope at any point c. So my values of c would be the, we'd have 2 different c values that work on this one. The x-coordinate of this point and the x-coordinate of that point. So let's look at an example. This example down here says, show that the function, this is a parabola, satisfies the conditions of Rolle's theorem on the interval from -2 to 3, and then find all the values of c that satisfy the conclusion. All right, so for the conditions, since f is a parabola, or I guess I should just say a polynomial, f is a polynomial, so it's continuous and differentiable. All right, so now what we have to do is find the values that satisfy the conclusion. And just realize this is Rolle's theorem. It's supposed to be the mean value theorem. All right, because it doesn't satisfy Rolle's theorem on that on this, and we'll see. F of 2, f of -2. This is my A and this is my B. So f of -2 is going to be 4 plus 6 minus 2 is 8. Or is 8. And for B, f of 3 is going to be 9 minus 9 minus 2 is -2. So yeah, it doesn't satisfy Rolle's theorem because these 2 points have different y values. But for the mean value theorem, all we have to do is show that it satisfies that. Okay, so the slope we're looking at, f of b minus f of a over b minus a, that's going to be -2 minus 8 over 3 minus -2. So what is that? Negative 10 over 5. So that's a slope of -2. So what this is saying is we need to find the points in between where the slope is -2. So let's see, the derivative of this thing is f prime of x is 2x minus 3. And so f prime of c is supposed to be equal to 2c minus 3, which is negative 2. All right, so 2c equals 1. So c is a half. All right, now that's our answer. But let's look at the graph of this on Desmos and see. Now I've already got it graphed, so let's switch over here. This is, let's see, I've got it in x squared minus 3x minus 2, and I've got the 2 points that we want. Let me get them both up here into view. Minus 2, 8, and then 3, negative 2. So this is saying if c is 1/2. Now on this Desmos sheet that I have, I've got the value a there. I'm calling the variable a that's supposed to be my c. But if you look at that, I think you can tell that's parallel to the line that goes through those other two. And if you can't tell that, well, let's put in another thing. Let me move this up to the top so you can see it. What I'm putting in here is the line y equals negative 2x plus b. I'm going to add a slider. So this line, you can see it is parallel to that. And if I move it up to the right place, you can see it goes straight through those other 2 points. So this right here, this 1/2, x equals 1/2, does satisfy this. This is a parabola, so that's the only one that satisfies it. All right. The homework for this, I think it's asking you to do a couple of problems that are similar to this, a couple for Rolle's theorem and a couple for mean value theorem. So that's it for this section.